Hello, I'm Simon, also known as Polyhop. This is a special edition tutorial series covering the new POPs operator family in TouchDesigner while we're still in the experimental build. Today we'll be focusing on the particle pop, spawning trails from the motion of any video input. This could be applied to pre-recorded video footage, like this traffic video behind me, generative artwork, or even used as a real-time camera effect like so. Now, this tutorial uses build 2025-3280, so a fair warning that things will likely change between now and the official release. My hope is that this methodology can be recreated in the future, but there may be differences if you're watching down the line. And before we begin, I want to thank all my Patreon supporters and give a special thanks to my top supporters. On Patreon, you'll gain access to exclusive example files and tools, can vote on future tutorial topics, and more. So yeah, let's get started. The first thing we want to do is build out a little particle feedback loop with pops. And so I'll start with a grid pop. We can use this for a sort of temporary input for our initial points. We'll swap this out later, but this will do for now. And we can maybe jump to 50 by 50 for our rows and columns, so we have more points to work with. We'll leave it the same for now. And then let's create a particle pop. So this might look pretty familiar if you've used the particles GPU example found in the palette under Tools. So similar stuff, we've got birth rate, life expectancy, and a variance for the life expectancy. It's dealing with velocity, mass, drag, velocity dampening. It is a feedback loop, so we could let it all happen inside of the particle pop, but also we can point a null at this target particles update pop. Really, any pop is fine, but I think it's best to end feedback loops with a null, and we can start adding things also within the loop. And so that's a nice affordance of this system as well. But yeah, just wanted to point out that similarity there if you already have some familiarity with the top-based method. So we've got ourselves our particles. They're spawning, randomizing those initial points. For now, we'll leave these settings the same, and we'll kind of fine-tune those later and as we go. I want to continue with a null, which will be our end of the loop, particles end. And I'll drag that onto the target particles update pop parameter. I will make these both a color because it helps me visually see where that loop starts and ends. Totally optional there. Then next, let's add some noise so that we can start pushing these around a little bit. So inside of this loop, I'll add a noise pop. And immediately it does something kind of funny. It is moving a little chaotically, and they kind of get stuck in these little locations where they're stopped and like looping in weird ways. This is because by default, our noise pop is adding to our position attribute. Now, this is the same for most feedback systems in chops or tops. Whenever you're dealing with points that have a velocity and a position, we don't want to add to our position within the feedback loop. To get smoother motion, we tend to want to manipulate the velocity instead. And then, here's where our simulation is happening, and it's actually doing some velocity dampening, things like that, before it adds the velocity to the position on each loop. And so the nice way to do this is instead of adding to position, let's go ahead and add to part velocity. So, you might say, where did all these come from? So the particle pop is creating a bunch of attributes that have to do with the particles. The age, the drag, the force, there's an ID that each one has, a lifespan, mass, and part velocity. So particle velocity is what we want to manipulate, and you'll notice that it already has a smoother quality to the motion. So that's what we want. Let's also toggle off noise. We have this noise attribute it's creating. We don't need this. It will just clutter up the attributes. So I'll toggle that off. And I also want to combine the curl 3D. I think that's going to be a nicer look. But we can switch between those later. It's really easy to choose your noise type. So yeah, we've got ourselves some particles moving around, and that's great. One thing I want to point out too, you'll notice that the noise attribute is still here. Because this is a feedback loop, we do need to initialize and restart it if something like the attributes change. So you'll notice now there's no noise attribute, but that was because that was in the feedback loop. It wasn't disappearing just because I turned it off. It was still passing it back and around. So just something to note when you're dealing with any kind of feedback loop, pops included. Okay, now that we have these points, I'm going to go ahead and add the trails, since I think that'll give us a nice idea of how they're moving, and ultimately we are going to be drawing trails, so we might as well get that going, and also the render portion so that we can dock that over to the right. So let us create a trail pop, and right off the bat, it's honestly pretty wild and not what we want. You can kind of see the trails happening, but then they're connecting the wrong particles. It's not great. And so one solution here, which is a really handy method built into the trail, is the match by attribute option. So we'll toggle that on, and we can choose part ID, the ID from the particles, to say, hey, let's connect these based on their unique identification. And now we see them connecting nicely. Now, a couple things to call out. This is fine while we have only 100 particles or points in our system being used, but if we did get up to 1,000 and we're reusing points in our ID loop, you'd start to see discontinuities. If like ID 0 dies and then immediately is reused, the trail, which is recording over 1 second or 60 frames, is going to treat that as one entity, and it's going to jump back and create these like lines that jump around. We don't want that, and so I'll preemptively say let's not reuse our point. So our point IDs, they're just going to keep incrementing forever. Well, not forever, but for a long time. And then, yeah, and we also probably want to link the number of maximum points with our max number of line strips. This is another thing, is if you cranked up the maximum particles and we had 10,000 particles but only 4,000 line strips, you'd also get some weird jittery kind of like discontinuities happening with our trails. So we can go ahead and link those values. I'll drop the maximum particles over onto the max number of line strips, and I can even make this a bind if I want to cut and paste that reference. And I know we're going to want this to be higher, so I might even set this to like 1,500. It's not going to use all of those points, right? We see that it's only in the like sub 100, right? But eventually, when we increase the birth rate, we'll see more particles being drawn. All right, and now we have our trails, and let's go ahead and render this. So I'll add a geocomp, call this lines, and I will also add a line material. For our line material, we can go ahead and set this to a thicker line. I think I have around 10, and under color, under the line tab, turn off specify line far color and set this to like white. So we'll manage the color ourselves. Let's go ahead and add a simple render network here as well. So I'll add a render, set this to 1080 by 1080, and I'll set a camera. For this, let's use orthographic with a width of 1. Since we're going to be using a video input, I'm going to want this to line up exactly with our input, and so and we'll keep our input points x-axis always from -0.5 to 0.5. So this ensures that we will be lining up our video with our output. If you're using a different aspect ratio, that's fine, as long as your input aspect lines up with the render, and then also you want to make sure that the x-axis is the one that goes from -0.5 to 0.5, with the y varying based on the aspect ratio. So yeah, here we go. We've got our lines, and going to create, it could be an out or a null. I'll turn on the display flag. This is just how I like to view things. I'm going to go Alt left bracket or split left right, Alt 4, or you can drop down here and say top viewer. I'll drag this window split over a little bit, and then on the left, I want to not display our backdrop tops. So a little bit cleaner. Another thing I'm going to do preemptively, we'll see this start to show up visually as we go, is add an SSAO or a screen space ambient occlusion top. And I'm going to dial this in, these parameters, based on what I know I want later, but you might tweak it a little bit, or especially if you're having performance issues with it, you might want to kind of dial down the quality. But I'll bring up the sample directions and sample steps all the way to 20 and 30. The surface of void can be 3. I want this at a full resolution. It's because these lines are pretty small and close together, and I actually want the shading to be pretty subtle. I'm going to set the SSAO radius to 0.01. I'll bring the contrast down and the blur radius down. So you really don't even see anything happening now, but once we get more particles and trails, we'll start to see some of that come into play. Last thing I'll do here is I want to tweak the parameters on my noise a little bit. So one thing is, they're flying all over the place, and this noise will ultimately just be adding a little bit of like chaotic character to the velocity that will ultimately come from our video input. And so I want to decrease the period quite a bit. I want the noise to be kind of like smaller in its motion, and then also the amplitude. Let's make this much smaller, 0.001. You can explore different values for the number of harmonics, but for our purposes, let's set it to 1 and bring down the harmonic gain to say 0.5 something. So this will add a little bit of like variance in our particles, so they don't all feel like they're moving exactly the same. They have a little bit of character, but still, primarily we're going to want this to be driven from our motion from our video. The other thing I'll do is on our particles, let's go ahead and increase the birth rate a bit. We'll maybe increase this higher later, but I'm going to change this to frames and set this to say 50. So you're going to get a lot more, like a much denser look here. You're starting to see a little bit of that screen space ambient occlusion. I do want to drop the life expectancy to 2 as well. So I want these to be shorter, but more frequent in terms of how often they spawn. The other thing I will do here is add a little bit of initial velocity in the Z, so that they're coming towards the camera. So this, again, you'll see a little bit more once we actually plug this in to our video input, and then some velocity dampening. So slow it down a bit. So yeah, we're starting to see some things happen. I think the one other thing here is we might as well add a little bit of animation to our noise. So like abs time .seconds times 0.1 to start. So that way it's not just static noise that's being added. So this is looking cool, but they do kind of pop in and out of existence in a way that's distracting. And they're also all the same thickness all the time. So they're uniform in their line width. I want to give their profile a little bit of variation and also make it so that they start small and end small based on their age. So not just the length of the line, but like when they're born, I want to have that portion of the line grow and then decay when it dies. So we can do this by manipulating the LineWidth attribute. I'm going to create a base in line before my lines, and I'll call this LineWidth. So let's jump inside, and this is where we will define our line width. First, we're going to create an attribute to represent the age of the particle as a normalized value between 0 and 1. Taking a look at the pop, we'll see we have those particle lifespan and particle age. So that's how long in seconds the particle will exist and then how long it has existed. And so we can actually get a fraction from that, which is what we want ultimately. And so I will create a math mix. And under combine, let's choose A divided by B. And here we can grab our part age and divide that by the part lifespan. Now I'll just call this age, or you can call it age fraction or something if you'd like, but we're only using it one time, so I think it's fine to call it age. And then from here, we have this value now from 0 to 1 that represents its age from life to death. So we can use that with a lookup texture and to sample from a ramp top. Now that's just a way I like to define the thickness of lines, but you could use other ways of sampling either in pops or chops too. There's other lookup methods here, but I like defining them in a ramp top. And so I'll go ahead and make this 1080 wide and also 32-bit float. Drop a null here and then use that for my top. And we don't need a V lookup attribute, that's the vertical component. Let's just use the attribute U and choose H that we just created. And then now for output, let's set the channel mask just to R. We only want the red channel. And under this little caret, we can choose line width. So we already have things happening, though I know that I want this to start at 0, just stay at 1 for a while, and then go back down to 0. So now you'll see that when these are spawned, they grow for a period of time and then shrink as they die. So it's not popping in and out quite as much, which is what we want. So now let's add some variation so that it's also not a uniform thickness for the course of the line. This, I tend to use the line metrics pop. And so under line strip, we can get the distance from start normalized, which is a 0 to 1 value from the start to the end of the line strip. We'll just toggle that on, and we can use this same method here. I'm going to copy that same structure, the lookup texture, plug that in. Instead of line width, let's call this profile, just really something else to differentiate it. And instead of using our age for our lookup attribute, we will use just start normal. And let's give this a little different shape. So maybe it has kind of a thicker head to it and then tail like a snake kind of. And you could even add a bump to it if you want. Give it a little squiggle. And let's set this to ease in, ease out. Actually, let's do that to both shapes. Cool. And now we need to combine profile with our line width. So I can actually make this continue to be in line, and we'll use a math mix for this as well. Under combine, A times B, and I'll start with line width, since it'll then show up in the result scope automatically, and profile. Cool. And so now, we have these like varied shapes, and they kind of like grow when they're born and shrink when they die. So we're not seeing that same kind of like flickering that was distracting to me when they're born and when they die, which is one of the big things that I'm doing here. But again, I also like adding that variation in the thickness too. And you can kind of see it too if I zoom in a little bit. It's very subtle, but that screen space ambient occlusion is giving us a little bit of shading. It's pretty subtle, but that's really what I'm looking for. Is just so that we can start to differentiate between similarly colored lines. Once we have this sample the color from our video input, there'll be more ways to differentiate it, but I found that that's like a nice little touch. Okay, let's move over to the left of our existing network and drop down a movie file in. So you can point this to any movie file you'd like. So I'm going to be using this video from Tom Fisk, who has a collection of videos on pixels. So this is a nice little aerial shot of traffic moving. And one thing I like about this kind of movie is that the background is really static while you have motion on top of it. And so for this effect, you get a really dramatic, like, oh, here's the moving things that are causing the particles to spawn. Whereas if you have a shakier movement, you'll get a more global effect as far as where you're seeing those particles draw, because we're going to be looking at motion on pixel level. So it won't necessarily be doing the tracking to know, oh yeah, the particle, like the whole camera moved. It'll just see, oh, this pixel moved, right? And so that's just a note. I think that this kind of thing works really well. So I'll be using that, but you should definitely explore all sorts of inputs for this. Live inputs, generative inputs, video inputs, things that you've got floating around. I think it's a lot of fun to explore, and sometimes you find really unexpected things that way. So let's go ahead and create a fit top. And we want this to be the same aspect as our output. So we're good here with a square. I might even make it the exact resolution because I'll comp these later. And fit. Let's set this to fit outside. And then I'm going to drag the translate over a little bit for this specific one because I like that composition of the diagonal overpass. And so here I can drop a null down and I'll call this source. So from here, I want to analyze the motion of this video. And so I will use the handy optical flow in TouchDesigner's tools. Let's see where that is, optical flow. Now this is has some limitations. You'll notice that you can't really see it maybe in the capture, but it's flickering a little bit. This is most likely due to the sample rate being 29.97 versus the FPS being 60. So like every other frame, it doesn't actually register any motion. And also you'll notice that it's really only getting the motion on the edges, which can be a little bit like limiting for certain kinds of inputs. It's not giving you kind of like, if your hand moves, it only sees the edges of the hand moving. But for our purposes, this will work. And I'm also going to add feedback after this that will smooth out that motion. And when I say motion, I'm talking about the red and the green channels here are representing the X velocity and the Y velocity of our pixels. So just, if you're not used to thinking about tops as data. So let's go ahead and drop a base down here and call this feedback. And I'll jump inside. And I'm going to use this to kind of create some velocity trails. So over time, we're just adding the velocity and then it decays, which can have, that way particles have this like follow through. If there's motion left to right, things kind of follow it for a period of time, that kind of like decay in the velocity. So let's start by adding a feedback top, and then I will drop a null here called end feedback and point that to my feedback 1. You'll see it shows up in the target top. And now I'm going to add a blur top. I don't necessarily think it's going to be useful in every instance. In fact, for this specific movie, it's already pretty smooth, so I don't need it, but it can be a nice way if you've got really noisy motion and you want to blur it a little bit in this feedback loop. And then I'll also use a math top. And this, I will be using the multiply and set that to 0.95. And then I will go ahead and just add that to our in our feedback loop. So now we have these trails, red and green trails, that are representing the X and the Y. And some things you're not seeing here because this is 32-bit float. There are some negative values. So it's going actually from negative 1 point something, negative 2 to 2. It depends on the motion really. But the gray here is actually 0, and you're getting negative values in both directions. Cool. So here's our little feedback loop. And from here, I'm going to drop some nulls down to represent things like velocity that we'll sample later. We could use this for color. I like branching off of this. So I just say, here's my Here's my color top. And we also want to use a math top here. And I'm going to process this a little bit to give me a value that represents, like, is there motion? I want it to be more of like a active variable. And so here I can use length because I want to know, I want to know the length of the velocity. However, and I also want to use a channel post-op as positive, since I want both the I don't necessarily want negative values here. And then I also need to combine the channel input. I'm combining the alpha as well, and for whatever reason, I could drill down to see why this happens, but we've got like a value of 20 in our alpha. And so here I can just ignore that. I can say I only want to combine R and G, our X and Y. And then for the output, just so it's a little easier to read, let's just combine all the channel output. So this result is being output to every single channel. And now we'll see white pixels that have a higher value based on the intensity of the motion. Cool. So we can call this active. And I'll give these all colors. One thing I missed on this feedback top, which might be nice, is just to customize it so you also have these controls at the top level. Yeah, I can drag on the multiply, bind new pair as master, and same for filter size, drag that over, bind new pair as master. And then for the gain parameter, let's set the range min to 0 and the range max to 1, since those are really the values we're going to be looking at. So now if I go up a level, you'll see we've got the multiply and filter size at the top if we want to, say, increase or decrease that level of feedback. And then also the blur, you'll start to see how that visually affects the output. Cool. So now that we have these sources, we're going to move those over to pops. Just drag this up a little bit so we can use them with our particle pop system. So to start off, let's go to the color and right click and go to pop and top 2. So right off the bat, we have actually a set of points. The way that it samples is you get a point per pixel. So quite a few points here. And we're also going to want to pull in some additional tops as other attributes. So let's click the plus. We want to pull in active. And let's not set this to color. Let's set this instead to an attribute called active and only pull in the red channel. We only care about, that's a float. It's, doesn't need to have all the channels there. Similarly, let's create one for velocity. And I'll call that velocity, just VEL. And I only want the red and green channel scope here, since it's the X and the Y components that we have. Cool. So now if I middle mouse, you'll see there's an active attribute, color attribute, and a velocity attribute in addition to position. Before I combine this with my system here, let's also delete points based on that active attribute. That way, only things that are moving will get fed into the particle pop and thus spawn points based on how much they're moving. So I can go to delete, a delete pop, and under attribute, let's choose active. And then we can just drag this value up, and it's basically a threshold for what points are deleted based on the motion of that video. And so now we're pretty much at the point where we can just plug that into our particle pop instead of the grid. So you should automatically start seeing those particles spawn based on that, that input. So before we move on too much further, I want to comp our color top, that null I made. So I'll select the top called color, assuming you named it color. And let's just place these over one another so we can see what we're doing at the end. That way we're drawing our particles on top of our source. And now we can see, yes, they are being spawned based on the motion in the video. There are a couple more things we want to do. For instance, right away we can say, oh yeah, we're not actually applying color yet. This is a pretty easy fix. So under particle pop, let's go to the attributes tab. And here's where we can say what attributes we want to pass in to particles as they spawn. So we can choose color. And now automatically we're passing along the color attribute. Let's also pass, I called it velocity. I think I actually want to name this, let's jump back for a second, velocity init for my initial velocity. So this will be the starting velocity each particle has. It won't change over time necessarily unless we tell it to, but this will be like, okay, if it spawned, how much was it, like where was it moving when it was created? So I will, oh, did it disappear? Didn't like me. Oh, yeah, whoops. Not the top. Velocity init is the name of our attribute. Okay, there we go. So yeah, now we can see that show up here, velocity init. Cool. So those are the two we want to pass along, and we need to do something here to not only like pass on that initial velocity. That's one thing I want to do is say, okay, when you're spawned, inherit that like motion, but I want that to decay over time. So it's kind of an initial burst that has a built-in decay. It's not necessarily going to automatically decay with the velocity. It's a separate attribute. So the other thing I want to do is take this velocity map and sample that based on the position of each particle. That way it can continue to move based on the motion of the video. So those are two separate things that we'll combine with the velocity in combination with this noise. So a lot of different things that are kind of subtly impacting our velocity. So we'll start by actually dropping down a lookup texture. So we can go ahead and just right off the bat sample this velocity based on our position. I'll drop that down here in the velocity, the top. And then for lookup attribute, let's use position 0 and 1. Because our position goes from negative 0.5 to 0.5, let's also add a 0.5 lookup offset because we're expecting normalized 0 to 1 values. So we'll want to shift that a little bit. The other thing we want to do here is set an output. So I'll set this to velocity. It's different than, our particle velocity, right? So we'll combine those later. And we do need a channel mask here. We want to make sure that this is only, we can set it to 3 components. That's fine. It's not happy with me. Too many output components. I think I need to reinitialize this. There we go. So it already had a velocity attribute in there. So sometimes that just helps if you get a warning, is to reinitialize your particle. And now we should see a velocity. It's a float 3. And now we can combine quite a few things with our math mix. Let's go ahead and drop that in. So I will first do an A times B, and let's pull in our velocity our initial velocity. And I want to make this decay over time. And so under uniforms, let's add a decay uniform. Can be a float of 0.95. So this is a nice tab where we can just add, some constants that we can use in our combine portion. So I will go ahead and drop decay down here. So this should be decaying over time. We can also click plus to say, now let's add our initial velocity to our part velocity. So we'll do part velocity plus initial velocity. And it's not happy because it says, oh, your initial velocity doesn't have enough parts in the scope. So there's different ways around this. One thing we could do would be to, instead of using every portion of part velocity, just do .xy. And there we go. It's really going now. So our initial velocity is like way high for how large this area is. If we hit A and then N, and you'll see, oh yeah, we're going like -2 to 2. If you think about it, our whole area is like a 1x1 in size. So they're just getting like blasted way outside of the view. So we definitely want to tone this down a bit. Let's drop a math top in here. and I'll go to add and just multiply this by like 0.01. And here we go. So now they're getting pushed. They're actually getting pushed like backwards. So that's something you could always flip that if you wanted to. If you wanted it to move in the same direction as the motion, this could be a negative value. Might be nice for like if you have like a webcam input. I would definitely suggest keeping that the same. In this instance, I actually like that the trails are going the opposite direction because it feels like kind of like exhaust or like particles flying off of the vehicles. But again, this really is going to depend on your specific instance. So the other thing here we haven't done yet is add that sampled velocity. So we can still keep this same math mix and go to operation, and we still want to do a plus b. We're going to say part velocity and then velocity. And this one I did make RGB. If we were just choosing RNG, you could do the same part velocity.xy, which just says we only want to use those two components. But yeah, now, a subtle difference, but they're going to keep moving a little bit based on this velocity map. So like, for instance, for interactive inputs, if you waved your hand in like a circle and created that kind of pattern, those particles would continue to move in that way, even if they were recently spawned. They're going to keep sampling that same map of motion. You might also, I think I dropped these birth rate down, but in some examples, I think I have that almost up to like 100. And you can certainly see how close you are to that maximum number of points. So I'm still under 1500, but if I dropped this down to 50 again, you'd see that number drop. So those two are very much related, like that maximum number versus the birth rate. So something to keep in mind. You can play with that as well. The noise quality, you don't need this at all. We drop the amplitude completely, and now we're really just getting like that motion is really fixed on, and kind of like looks a little bit weird with the lines overlapping one another. I do really think that a little bit of noise here is nice, especially with like a low period, because it still maintains pretty much the same direction, but it has a little more chaos, a little more like interesting motion that particles don't feel like they're just doing the same thing. So that's like, I think, a nice flavor, but you can play with how extreme this is. Like a bigger period, you're going to really see the shape of the noise in the output, right? Whereas if this is really low, it's just kind of disturbing it almost. So some things to play with, different inputs. I'll also say, you might want to keep an eye on this, this active threshold, right? So like how much noise, like if we increase this a lot, you'll start to get noise from the trees even that are spawning particles. So this will help make your effect more coherent, or you might need to lower this if your velocity values are lower. So this is going to go hand in hand with your feedback, with the filter size, with the kind of multiply value. You might pull all of those out and make a tool out of it, right? So there's a lot of different things at play that you want to go back and forth and really dial in based on your specific video input. As I mentioned in the intro, it's pretty straightforward to add your own video input. You'll see here I have a video webcam source. Hello. And it right off the bat, I'm going to move away from the mic. You'll see it just like doesn't really respond particularly well. Right. And so this was tuned for this previous video input. So we'll just have to make some adjustments to some of these parameters, and it will be unique on your end just based on what kind of input you have. So one of the key things here is this delete pop. The threshold is pretty high. So bringing that way down, we can start to see it's already way more responsive. But one thing that I want to change here is I also want a little bit more motion from my input. And so to get that, I can go to this math. And in addition to increasing this, I'm also going to flip the direction so that it is going to move with my motion. So already a huge difference. It's spawning a lot more particles, and they are moving, with my motion instead of reverse, which I liked it, as a reverse input for the traffic, but in this instance, I do really like it moving along with my motion. So there you go. You can see how it didn't take that long to get it where I wanted to. You might even also increase this filter size. That can kind of smooth out some of the random spawns from the noise or grain in a video input. And even then, it's like some of the stuff on my walls is activating, which is fun. But you can certainly filter that out. Doesn't look like this is having a big difference there, so you might have to play with some other things like the delete threshold and so forth. You can kind of. There we go. So yeah, it's a really case-to-case basis, but you can see how it did not take long to get this video input into the system. So hopefully you have fun playing with that as well. Also, if you're looking for more resources on the particle pop, I would recommend checking out Function Store's tutorials on the subject. At the time of recording, he has 2 videos that I'll link to in the description. And while there's some overlap between what I'm covering here, I'll say Dan touches on more topics than I cover in this video, so it might be worth jumping into to see more of what you can do with particle pop. So that's it for this video tutorial. I hope you have fun with this technique, and thanks so much for watching.